Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me RouterBob. You know, one of the most amazing softwares to ever be developed for this industry is Mosaic. And a lot of our customers now are using Mozaik software with their ShopSabre CNC routers. What I really wanted to do was to create what you might call a little quick start plan to help you get to the point where you're ready to make that first cabinet on your new CNC. But before we do that, let's take a little look into the training and to support those kinds of things that the software comes with. You know, a logical question you might have is, how in the world am I going to learn to use this software? Well, here's how the system starts. You're going to receive an email from Mosaic that will have a link that allows you to download the software to your computer. All right. Now, you're also going to receive 2 hours of online training. One of them is an introduction to Mosaic, and one of them is also has to do with the back end, what we call integration. It's more related to the machine part. But you know, the real way you learn it is through a series of videos, and we'll look at those in a minute. Now, once you install the software, a screen will pop up the first time you open it with a user ID. You email that to Mosaic, and they'll send you the activation codes. Then your software is ready to go. Now, that's where we're at right now. Let's look at my computer. You know, probably the easiest way to learn this is to start with the videos. Now, let me show you how you get to those. On the main screen here, if you go to Help, Training Videos, these are actually on YouTube, and you'll see here's a whole list, and they basically include almost every activity you might want to do. I would probably start at Introduction to Mosaic, and you'll see this comes up, and we'll go full screen on it. And it's a video that just walks you through step by step and explains things. So the first thing you do is actually watch these videos.
This will be a quick introduction to Mosaic, how to start a job, how to lay out a simple wall, place cabinets from the library, use the autofill feature, and check your parts. To start a new job, simply click File, New, give your job a name and number.
So that's basically where you start. So I would start, my recommendation is do an hour at a time and go through the videos, watch each one of them. Okay, now, so that gives you the basic fundamentals of how the software works, and it's also a great reference if you can't remember everything. Now, you're also going to get 2 hours of online training that's included with Mosaic. That first hour will be an introduction to Mosaic, and the second hour is related to the machine part, the integration and that part, the tool pathing and that part. I would recommend it as you begin learning this that you make a list over here and that you name that list Ask Mosaic. And every time you come up with something you don't understand, put that on your list. Then once you contact Mosaic, then make sure those questions are answered. Now, down the road, you may have other questions as you get into more customization and stuff. It's very typical for a customer to probably invest in another 4 to 6 hours of online training. And I would do that 1 hour at a time. Mosaic charges $75 an hour, and you can contact them and schedule it. I think that's probably the way to do it. And once again, keep your Ask Mosaic list out, and as you encounter something you don't understand, get that covered in training. So basically, that's where I would start. Now, what I want to do in this video is I'm going to give you a brief overview of how all this connects, and then we're going to go through and we're going to start with how we design a cabinet and actually carry it all the way through CNC. So that's our next step. Okay, now let's take a look at a sample job. All right, when you install the software, this sample job called Frameless Example comes up. You'll see it right here. Let's take a look at that. Right now, in fact, let's just skip down here and look at the actual room itself. This is what the job looks like, and let's look at that in 3D. And we'll probably have to slide that shadows over because of the graphic card. All right, so that's what it looks like. There's the kitchen that's already designed. All right. So that's a good place to start, but let's back up here. We go back here to the Settings tab, and basically the settings determine all the little details about how this is done, what kind of doors it has, what kind of hardware you're going to use, all those things. It also has a concept of what we call a material template. A material template simply says, this is what I make each part of the cabinet. That's what determines that. In fact, let's deviate from this a little bit, and let's go to the libraries and look at 2 different libraries. The first one is materials. Now, these are the materials that we're going to use. For instance, the first one's a 3/4 plywood. It's 48 by 96. The thickness is 3/4. Now, because we're using CNC, you need to mic that material. So if it's 0.4 or 0.742, that's what you need to enter. because that's used to create joints and make sure they fit. And the other thing here, these other things you see here are the trims. Like, I probably would set the trims to 1/8. It just saves material. Now here's what a trim is. It means this is how close I can nest a part to the edge of the material. So 1/8 of an inch is plenty close, right? So you go through here and you basically set these materials up to match the materials you use. Then there's another concept, and that's called a material template. And here's what this is. This basically says what each part is made out of. So you notice how it picked up these the thicknesses here. It automatically updated that thickness. So basically, that's the material library and the material templates. Okay. So we'll get back to our settings. So that's what's accessed over here. So that's what this part of the settings tab is. And of course, you've got the rest of the stuff. Now, let's go to the next level. Then we define our room. Once again, the room's been defined. There's some preset rooms here, and then of course you can draw custom walls and all that kind of stuff. Most of that information is placed down here. We progress on through here, we see a product tab, and let's just pick, when we get to the product tab, we can actually look at the front. So let's pick that cabinet, and let's go edit. And that gets us for the cabinet editor, and then we can kind of look at stuff. Let's go to SketchUp this time. All right, now this is looking at the cabinet in SketchUp. Now the first time you open SketchUp, you may have some default screens that you have to say don't open at startup. Now there's some things I've added also in SketchUp and on the toolbars, and that's some of these toolbars where you can actually see through. All right, I'm actually going to show you on the toolbar. These are what, I'll leave these up for just a second so you can refer back to this. These are the different things I have clicked on here. And the reason I did that is it just makes it easier. So when you're looking at a cabinet here, especially if we're configuring a cabinet, I want to see what it looks like inside. So that's a really, really, really nice way to do that. All right, so that's SketchUp. Now I could also have viewed the same product over here on the viewer if I wanted to. I could also view it like this. Just another way. Okay, we'll close that. All right, and then as we progress on through here, then you have tops, and of course it builds the countertops on here, and also moldings. So you can actually have moldings, and we'll look at that once again in the viewer. And we'll get that. So there's your countertops and your molding. So that's all part of a cabinet job, of course. All right. Now, there's another thing here called order. Now, right now, this is a list of all the cabinets in that job. We're going to come back to this later because the order tab actually gives you the ability to make cabinets without any pictures. A lot of times you just need a cabinet of a certain size, and so we'll come back to that later. The pricing tab has to do with the business end of it. We typically wouldn't, that would be something you would work with Mosaic on. And then we get to the cut list tab, and the cut list tab opens up the optimizer. So we come over to the optimizer. I'm going to select that 3/4 plywood. Now we're beginning to get into the CNC part. So there's the optimizer. Now there's our material thickness that got carried over from the material catalog. There's the material size. There's those trims that we put on there. And the next thing I do is optimize it. Optimizing is another word for nest. And here's what the job looks like. And there's what one of the sheets looks like. Now I can't really go to G-code because I haven't set that part of it up yet. Now when we come back in here with our individual base cabinet, we'll set the rest of the CNC stuff up. Now let's focus on actually making your first cabinet on your ShopSabre CNC. First thing I'm going to do is teach the software how I want to build a cabinet. So that's the construction method. And basically we're going to use what I call a CNC construction method, and I recommend that's where you start. Typically what we do is we build a base cabinet, a wall cabinet, and a tall cabinet, and put them together, and if these all fit, everything else pretty much works. But let's stick to start with one of our proven methods. Now, the software has unbelievable capability, and you can virtually build anything. So you can create a very unusual construction method, or a cabinet for that matter if you want. But let's keep it to the basics first, because remember, our goal in this is to cut that first cabinet on your new machine. Okay, so before we get into a job, let's go up and let's actually configure a base cabinet the way we want it. And here's how I do that. I go to Libraries, and I select products, and you'll notice up here there's actually a list of different type of catalogs. This is a frameless cabinet catalog. So that's a list of all the different kind of cabinets that are typically you run into in a job. I'm going to select one, and that has to do with a pair of doors and a single drawer, real simple base cabinet. And before we do anything else, let's look at it in SketchUp and see where we start. There it is. Okay, that looks pretty good, but I see some changes. Yeah, and you see how this toe's cut back here? I don't want that. I actually want my end panel to go all the way to the floor. Okay, I don't really want a nailer. I want to put a thicker back in there and see what the inside looks like. Yeah, that's probably okay. We'll probably put some screws in there. If you notice a lot of our videos, we screw the cabinets together on unfinished ends, so we'll probably add that feature too. Okay, so that's where we start. Now, how do you change those? Well, it's really not very hard. So let's go to parameters. First thing we talked about was actually our toes, so let's go into the toe section, that category, and where it says side toe recess, let's make that 0. Okay, now let's see if it did anything. We'll validate this visually. Okay, now you see our side toe, now it's not stuck back underneath there. Okay, that looks pretty good. Okay, now let's go back and let's actually tell it to extend the ends to the floor. So I'm going to select a category called ends, cabinet-based ends to floor. Okay, now, oh, by the way, here's something else. If you can't figure out what these are, if you hit this little help button, it shows you. It shows you what you get if you say yes and what you get if you say no. All right, so let's say yes, and let's go back and validate that. Now, that should give us what we're looking for our base. And there it is. So there's that looks good. So now our ends go straight to the floor. Okay, so we got rid of that. Now, let's get rid of this nailer. So what we'll do is we'll go to the nailer category. And if we put the width of the nailer 0, it will disappear. Okay, let's validate that. Okay, and it's gone. Now, here's something else. So I really, when I'm all said and done, my back's going to be the same material as the sides. So it's going to be thicker, so I don't need that much recess. So let's fix that. So that's going to be a parameter under backs. And there it is, back recess. Let's change that to 1/4. And let's validate that. Okay, that's excellent. Now, we'll change the back material in the material template, so that'll fix that. Let's look at the inside. Okay, it looks like we've got dado joinery. It's blind dado, that's good. I like that. Now, by the way, let's talk about dados a little bit. It's really, really, really critical that your material thickness be correct in the material catalog because the width of that dado is based on that. What I typically do on this first cabinet is I mic the material and add 5/1000ths. And usually that works out pretty good. If it's too tight, you may not be able to get the cabinet together. But in our case, you know, I can live with it a little loose because I can tighten that up. But that's where I start. I add 5/1000ths to what I measure, and that gets me in the ballpark. Okay. Okay. So now let me show you while we're talking about dados. Another little thing here. It's called slop that you might find, and you see these values down here that say slop. Dado width slop. So that's actually where you can make adjustments to the fit. All those slops are that dado depth slop. Anything that says slop is going to be an adjustment that you can make in the joinery itself. Okay, now let's go back and let's talk about assembly a little bit. Let's go back and look at our cabinet. Now, one of the things that CNC gives us the ability to do is actually make things simpler. Now, if you notice, here's a blind dado, so that part's probably going to be real easy to locate. But you know, if you watch a lot of our videos, I screw the cabinets together and I put those screw holes in there just to make it easy to put the cabinet together if it's an unfinished end. Let me show you how you do that. Okay, what we're going to do first is I'm going to go to parameters and I'm going to select fasteners. And I'm going to say, okay, for the first joint fastener I'm going to apply, it's going to be a conformat. Now, a conformat's a screw. It's a fancy screw is what it is. But what I'm interested in is it basically tells the machine to drill a hole. So that's what I'm looking for. Now, one other thing, that there's some logic built into that. It has to do with whether an end is finished or unfinished. So let's do this. Let's go to shape. Let's select that end, and let's make sure that it's an unfinished end. Okay, it is. Now let's look at it again. All right, now you see these holes. We'll do this. Now you see these, so there's a hole here, there's a hole here, there's a hole here. So now because that's an unfinished end, all right, now let's change one of those ends back to finish and see if the logic carries through. So let's take this one, let's just make it a standard end. So that would be a right end. Whoops. Let's go back and look at it. All right, now you see the holes are not there. Once again, the logic's built in. If it's a finished end, don't put the holes. If it's an unfinished, put it. Now, you know, in looking at this, I see something that I don't like. And you see this stretcher joint here, it's not dadoed into the side, which means I'm going to have a hard time locating it. Let's change that. Okay, that's determined by a parameter in dados. So we'll select that. And it's this parameter right here, stretcher dado. We'll make that a 1/4 inch deep also like the others. And then we'll visually validate. And there it is. So that puts that excellent. That's nice. So that way that part only has one place to fit. Okay, that looks really good. Okay. So I'm pretty happy with that. All right. Okay, so we've pretty much got our cabinet configured now. One thing that you'll run into sometimes is sometimes in the graphics software, it's hard to see the holes, but let me show you how you find out if they're really there. If I go to this Parts tab, okay, and I go to Unfinished End, and I look at it, I edit it, and I edit Operations, you see there's all the holes. So now you can actually see where those holes are. Now, I do see something that I don't like. Now, if you notice in these dados, there's holes there too, which this is a really good place to talk about what generated those. So let's get rid of those. All right, let's go back up here and let's talk about another concept. And that concept is, and we'll close this, that concept is called a joint template. So if I go back to Library and I go to Hardware, okay, you'll see guides. Oh, no, by the way, this is what determines where the hole locations are in your guides and the hole sizes. Hinges, pulls. What I'm looking for is fasteners. Joint template, and I'm going to select the one called conformat. So this is, when I select conformat for the joint, this tab actually determines all the settings. Now here's what I'm looking for. The locations, so the joint type. So right now, the joint between the back and the end, all right? The first hole, it's located. The second hole is located. See, it's saying 1 inch from the bottom. The third hole is on the center, and the fourth hole is turned off. Well, I don't want any of those holes. So I select each one and just say don't use. All right, now let's close that, and let's go back and validate it. So let's go back up here, look at our cabinet again. So actually, let's just do this. Let's just look at the part. Whoops. And we'll look at it in validation. Can't see them there, but if we look at the part level, we probably can. So let's go to the part level. Let's go to that unfinished left end, edit operations, and see they're gone now. So that's what that joint template actually placed those holes. So the locations of those assembly holes were put on it there. All right, that looks really good. So if you look at the part level, a lot of times you can see what operations are actually there. And then you have shape. You can control the shapes and the operations and all that if you needed to. In our case, we don't need to. Okay, we'll look at a couple more tabs here as we go down through here. Information, the size, of course, of the cabinet. Once again, that size is probably going to come from somewhere else. The shape, the face. Now, when you customize the cabinet, you customize the face first, then the inside. So the interior, the parameters, we won't get into too much of that at this point. What we're trying to do now is to actually create our first cabinet. So let's say I'm happy with all that. Okay. Now let's actually go to the next step and let's actually create a job with that cabinet in it, and that allows us to take it on out to the optimizer and eventually set the machine up and cut the cabinet out. I've taught the software how I want to build a cabinet. Now it's time to actually construct that cabinet that we want to cut on the ShopSabre CNC. So here's how I do that. Start out and I say File, New, and I'm going to call this Base Test. That creates the job. All right, now here's the Settings tab. Now you notice Settings for Room. There's actually two choices here. You would have more if you had more than one room, but in our case, I want to do an order entry, and that brings up an interesting point. You can actually create a cabinet that's part of a design that's going to be printed out as a graphic and all that stuff for a customer, or sometimes you just need to build a list of cabinets of certain sizes and certain designs, so you don't really have to have the pretty picture part. In our case, we're going to do our first base cabinet as part of order entry, so I'm going to select that. And let's look at the settings. We're just going to cut the box, so I really don't care anything about the doors and all that, but I am interested in the hinges. Let's make sure that we have a Euro hinge so that we drill the holes for the hinges. The drawer guides, I don't care. Let's verify the material settings. We're using 3/4 plywood template, and let's see if, okay, our unfinished back is correct. We've made that change. Okay, that looks pretty good. Then our next step then is to go to order entry. And then here's your product catalog. So let's select frameless cabinets. Let's take that pair of door single base and let's drag it up here. All right, so there's our cabinet. And let's select it. Let's see what we got. Okay, so there's our base cabinet. Now that should have exactly the same settings that we had earlier because we were setting global stuff. You notice now that we've got our 1/4 inch reveal here set back. Our back's the same material, same thickness of material, so that's good. We've got our holes and unfinished ends. So that looks pretty good. So that's pretty much, that's the cabinet we were looking for, all right? So we're going to say okay on that. Now we're going to move down through here. I don't care about pricing. I'm going to go to cut list. And that gets me to the optimizer. And we're going to do the 3/4 inch plywood. That opens the optimizer. I like to expand it. All right, this all looks correct. There's the material thickness, all that stuff. Okay, let's go to optimize. Well, I've got a problem here. I've got 2 sheets of material. Well, how do we fix that? Well, why don't we change the size of the cabinet? So let's close the optimizer. Let's go back over here to order entry and let's change this, instead of 24 inches deep, let's change it to 23. Because this, what we're trying to do is actually create our sample cabinet, so if it's a little smaller, that's okay. We'll overwrite that. All right, everything looks good. We'll optimize it, and hopefully that fits on one. Oh, and it did. So now that fits on one sheet. So all of our parts that we need to cut for our cabinet are on one sheet. So that works out pretty good. But we really can't create G-code until we set the machine up. So let's do that next. We've completed the design part of the project and the optimization. So now we're actually ready to start talking about machine integration. How we configure the software to talk to your ShopSabre CNC. So let me show you how easy that is. You go to libraries, you go to machines. This screen comes up, and these are default settings. So it says CNC router, it's set as the default machine. That's selected. If you have a boring block or a multi-drill, you'd select that, but in our case, we're not going to worry about that. Now go to the actual Setup CNC Router button. You notice in post-process, there's nothing there. All right? You say, well, you're going to have that because that's what configures the machine code, and you're going to get that more than likely attached to an email from Mozaik. So what I typically do is download that post and put it on the clipboard, and let me show you where you put it. So we'll drop back out here to the Windows Explorer. Okay, we're in the Mosaic folder. Double-click Data, double-click CNC, and double-click Post. That's where it goes. I right-click and paste it. Now it should be there. Okay, so let's go back over to Setup CNC. Now on our list, we have a post processor. And this one's called ShopSabre MMP, and it says it's for an ATC machine, and it includes ARCs. MMP stands for Mitsubishi Motion Platform. We just happen to name the post that. All right. So that's good. That's where the post comes from. Let's look at some other values here. Pretty much all this stuff is already set. So we'll hit OK. Okay, now we have that part set up. Now the next step then is to actually set up the tools in the machine. So let's look at that. Another part of integration has to do with the tooling. This is a part of the software we teach Mosaic how the machine's configured with tools. So let's take a look at how we actually did that. I start out at libraries and I go CNC tooling. And here's a list of tools that are already entered. You could also, if you want to, put custom tools in, it doesn't matter. And then you'll see a tab that says tool set. So tool set is a machine setup. Think about that. And there's some default ones. There's a full tool set and a basic and a cabinet. Now, what I want to do is actually create a new tool set because I want to show you how. So I'm going to say add tool set. And the new name is ShopSabre Pro 408. Let's just call it that. Oops, I better spell it right. 408. So we'll name it that. Now it could be MDF doors, it could be kitchen cabinet, it could be whatever. You can name a specific tool set for whatever the machine use is going to be. But in our case, we'll keep it generic. So we've got a new tool set. All right, so we're going to start out and we're going to put tools in there. Now, some people ask, well, what order do you put things? Well, it's arbitrary. But this has to match the way your machine is set up. All right. Historically, what I've always done is started with the order of operations. Normally, we're going to drill first, then we're going to do non-through machining, then we're going to cut the parts out. So let's start out with a 5mm drill. So I select the 5mm drill, I say insert it, and it's automatically going to be tool number 1. All right, let's look at the properties of that tool. Okay, there's the diameter. The through cut means how far through the material it goes through on a full thickness cut. I'm going to probably go through 30 thousandths on a drill. We're going to spin at 8,000 RPMs. Feed rates are 150. It's going to be a drill. All right. Now let's go back to our tool set. The next tool is going to be for non-through machining. Non-through machining is probably going to be dados. So we'll pick a quarter down shear and we'll insert that, and that's going to be in position 2. And we select that and look at the properties, and there's the properties. I probably change this to about an 8. The step over is after it makes a pass, how much it moves over for the next pass when it's cleaning out a pocket. So let's make that 1/8 of an inch. Rest of that's pretty good. Feeds and speeds should be good. Now, we're going to use this tool for dado, and let's look at the dado options. Run past just means extend the dado to compensate for the radius corners in the dado. T-bone's an interesting effect. And dog bone's an interesting effect, but we'll keep run past. All right, now let's go back to tool sets and let's pick another tool. Let's do, what are we going to do with the outsides with a 3/8 compression bit? So we'll insert that, and we'll look at its properties. And once again, there's a diameter. Now add the through cut. I've got set at 10 thousandths. So here's why. When you're cutting parts out and you're using flow through, you don't want to cut deep channels because vacuum leaks in your small parts might move on you a little bit. So typically through cut, what it's doing is it's actually taking the material thickness and adding 10 thousandths. And so that's going to give us a real nice finish. We're going to cut through all the way, and we're not going to cut too deep a grooves in the top of the spool board. Now on your feeds and speeds, I pretty much got this set up for what I would set up for a 508 Pro Series. If you have an IS series where you got a little more power and more speed, you can actually cut faster than that. If you go more than 800 inches a minute, you're going to have to go to a 3-flute tool, so keep that in mind. Now let's look at the profile options. Okay, when I click that, this has to do with small part handling, really. The top part, this ramp in means that the tool starts above the material and cuts its way in on a ramp. And we do that because it makes the tool life longer. I have helical checked so that it actually doesn't come in on the line, it comes in at a slight angle. That works much better when a compression bit gets a little bit dull. And of course the distance 1 is the length of the ramp, and it's going to be a linear ramp in. Now some people that are just new to CNC don't understand the difference between climb and conventional cut. So let's unpack that a little bit. Okay, a table saw is a conventional cut, a shaper is a conventional cut, a planer is a conventional cut, a joiner is a conventional cut. You're always pushing against the direction of the cutter. if you try to go the opposite way, they grab the parts and throw them. We don't have to grab the part and throw them consideration on routing because everything's held in place. So we can actually feed backwards or climb cut. Now, how do you know what to use? Well, it's the material. If you're using particle boards or MDFs or materials like that that are glued together particles, you probably want a climb cut. It'll just cut better. Okay, if you're using veneered plywood, you want a conventional cut. If you climb cut veneered plywood, some of the inner cores get real fuzzy. So it seems that if you use a conventional cut, it cuts much cleaner. All right, now as we go down below here, small part handling, let's talk about what that all means. One of the considerations we have is making sure that parts on the nest don't move, because you have a mixture of whatever happens to fit. So you'll have big parts and small parts. So what we want to do is we want to have the maximum vacuum whenever we cut the small part out. All right, so what is a small part? Well, that's defined down below under area of 144. So that means anything smaller than 12 by 12 would be treated differently, or the minimum dimension, even if it calculates out to a large part, if it's narrow, there's going to be a problem holding it. So we say, okay, if the part is 5 inches or less, we treat that special also. All right, well, how do we do that? Well, we're going to probably use what's called return onion skin. Now, the onion skin thickness is determined down here, and it says 30 thousandths. So onion skin thickness is basically about a 32nd of an inch is what it is. Okay, so we're going to look at all these parts, and the software is going to flag the ones that are small parts. And what happens when it outputs toolpaths, it's going to cut the outsides of those parts out, but it's not going to be totally disconnected from the sheet. It's basically going to be held by the onion skin. Okay, then when all those small parts are cut, then it goes back and the return part, it returns back to the first one. This time on that pass, it cuts all the way through on those parts. And the idea is that the cutting pressure is so light on removing those onion skins that the parts don't move. Then once the small parts are handled, then the large parts get cut. So that whole concept is called return onion skin. Now there's other variations. You can onion skin everything, you can do all kinds of stuff. But pretty much for nested-based cabinet parts, return onion skin is probably going to be your most efficient way of doing things. All right, so we've got that all defined. Now we're ready to actually generate toolpaths for our job. We've taught the software how the machine's configured. We've taught the software how the tools are set up. Now we're ready to actually output code for the base test cabinet and run it on the machine and put it together and see if it fits. All right, here's how you do that. You click this button over here that says Generate G-Code, and this screen comes up. Okay, we select the tool set that we're going to use. Once we select it, it keeps it. All right, so we're going to use that tool set we just created. We're going to use the post processor that we loaded, and I hit Calculate. And it comes up and it's done the tool pass. Now let's take a closer look at that. So the first tool that it found was the drill, and the second, the downshear and the compression. So as we click through these, you'll see that it highlights. See, the holes are highlighted. If I click through that, there's the dados and there's the compression, which is the outside parts. Now if we want to, we can say I want to simulate part of that. Now if you watch this, you'll see it actually simulate. See, those are small parts. So there's the first pass of each one of them. Okay, then it returns back and it cuts through the second. So that's the return onion skin. So it's basically treating the small parts first, and then it cuts the big ones out. So that validates what we talked about. So that looks pretty good. All right. The final part there. All right, so that validates all that. There's the last part actually over here. That's our back. Okay, so now after that we hit G-code. Now here's the next thing. The next problem you're going to have is, where did it save it? Okay, here's how Mosaic does it. Okay, if you look at where this is, if you notice here, let's go back a little bit. It's actually saving it in the Mosaic folder under jobs. So it'll be in it, whatever you name the job, is what it'll be called. So base test, okay, G code, and then the name of the material, that's where it's going to save it. And the program file is going to be called base test 3/4 plywood S1R1.tap, and it saves it. And that's what the G-code looks like. Well, I hope you enjoyed the video. I wanted to create a little quick start to help you make your first cabinet from Mosaic on your machine. This is not a substitute for the other training, so don't cut corners. If you follow the procedure I've told you, you'll be very successful. Everybody is. If you have any questions, you can contact us at ShopSabre.com. Thank you for watching.